Today, we'll be looking at how black holes are time machines. If you're new to this channel, welcome. This is Mr. Singularity, where we explore the scientific and technological breakthroughs shaping the future as we know it. Black holes are natural time machines that allow travel to both the past and the future, but don't expect to return to see the dinosaurs anytime soon. We currently lack spacecraft capable of approaching a black hole. Even if you ignore that little detail, attempting to go into the past via a black hole may be the last thing you ever do. What exactly are black holes? A black hole is a very huge entity that forms when a dying star collapses in on itself. Black holes, like planets and stars, have gravitational fields that surround them. A gravitational field is what holds us to Earth and keeps it rotating around the Sun. The greater the mass of an object, the stronger its gravitational field. The gravitational force of Earth makes access to space extremely difficult. That is why we create rockets. We need to fly at high speeds to escape Earth's gravity. A black hole's gravitational force is so intense that even light cannot escape it. That's remarkable given that light is the quickest object known to science. That's also why black holes appear black. We can't bounce light off them like we might bounce a torch light off a tree in the dark. Stretching space. According to Albert Einstein's general theory of relativity, matter and energy have an unusual effect on the cosmos. Space is bent and stretched by matter and energy. The larger the item, the more space is stretched and curved around it. A large item forms a valley in space. When items get too close, they fall into the valley. That's why, when you get close enough to a huge object, even a black hole, gravity pulls you in its direction. It's also why light can't exit a black hole. The valley sides are so steep that light can't climb out fast enough. As you approach a black hole from a distance, the valley it creates becomes steeper and steeper. The event horizon is the point at which the slope becomes so steep that light cannot escape. Event horizons are of interest not only to would-be time travelers, but also to philosophers, since they have consequences for how we interpret the nature of time. Stretching time. Time is stretched when space is stretched. A clock near a huge item will tick more slowly than one near a much less massive one. A clock near a black hole will tick much slower than one on Earth. As depicted in the film Interstellar, 1 year near a black hole may mean 80 years on Earth. Black holes can thus be employed to go to the future. Simply fly near a black hole and then return to Earth to jump into Earth's future. If you reach close enough to the black hole's core, your time will slow down, but you should still be able to escape if you don't cross the event horizon. Loops in time. What about history? This is where things start to become really intriguing. A black hole bends time so severely that it can reverse itself. Consider linking the two ends of a sheet of paper to form a loop. That's what it appears a black hole does to time. This results in a natural time machine. If you could get onto the loop, which physicists term a closed time-like curve, you'd be on a path through space that begins in the future and finishes in the past. Cause and effect would likewise become challenging to unravel within the loop. Things in the past cause things to happen in the future, which causes something else in the past to happen. The catch. So you've discovered a black hole and want to use your trusty spaceship to return to the dinosaurs. Best wishes. There are 3 issues. To begin, you can only travel into the past of the black hole. That means you won't be able to go back far enough if the black hole was generated after the dinosaurs went extinct. Second, you very certainly have to cross the event horizon to enter the loop. This means that in order to get out of the loop at a specific point in the past, you must first exit the event horizon. That involves traveling faster than the speed of light, which we know is impossible. Third, and most likely worst of all, you and your spacecraft would be spaghettified. Doesn't it sound delicious? Unfortunately, it is not. You'd be stretched flat like a noodle as you approach the event horizon. In fact, you'd be stretched so thin that you'd be nothing more than a string of atoms spiraling into the vacuum. So while thinking about the time-bending powers of black holes is entertaining, a trip to the dinosaurs will have to remain fiction for the foreseeable future. What's your take on this? Let me know down in the comments below and check out one of these other videos. This has been Mr. Singularity, and I'll see you on the next one.